and welcome to my virtual poster on quantifying the effects of feature similarity on attentional selection using psychophysical scaling. Many models and theories of attention have highlighted the importance of target distractor similarity in terms of its impact on attentional selection. However, there's surprisingly little empirical data quantifying what the shape of this relationship actually is. There's also little evidence for how similarity impacts attentional efficiency across different tasks, mostly relying on visual search, and also on different measures, such as by comparing response times with search slopes. Other studies have also relied on the distance between targets and distractors in their given stimulus space. However, research has shown that measurements within a stimulus space don't often map linearly to psychophysical estimates of similarity. So in all of our experiments, we used a technique called psychophysical scaling to get independent measures of similarity. And we used a task similar to this one, where we showed participants 3 colored circles, and we asked them to make a judgment of which of the 2 bottom circles is most similar in color to the one on the top. And we manipulated the distance of each of the colors around the color wheel so that we could measure how similarity changes as a function of distance around the space. So hopefully this first example, the judgment is pretty easy for you, and that you can tell that the circle on the bottom right is the one that's most similar in color to the one on the top. But if I show you another example, you might find this judgment to be much more difficult, even though actually the 2 circles on the bottom in this case are exactly the same distance apart in the color space as the 2 circles were in the first example. And so this just goes to demonstrate this psychological dissimilarity function. Here I'm showing you data collected across all of our experiments. And what this shows is that actually only small distances around the color space, say by 30 degrees around the color wheel, you've actually gone quite a long way in terms of similarity around the space. And so what we wanted to know is whether this psychological dissimilarity measure is actually going to better predict attention performance than just measurements around the color space itself. So in the first experiment, we were assessing how similarity affects visual search response times. So we manipulated the target distractor distance in terms of the search race. I'm showing you a couple of examples of that on the top there. And participants in this task made their response in 2 stages. So at first, they just clicked as soon as they felt they had found the target, and at which point all of the colors in the display disappeared. And then we had them make a manual mouse response as to where actually around the search array the target was, so that we got independent measures of both speed of response time, but also accuracy. And so I'm just going to show you the plot of the mean response times across target distractor distances. And so what we find is the strong nonlinear effect, where short distances around the color wheel show increases in response time up to about 40 or 50 degrees around the color wheel, at which point performance kind of flattens out. And we can also plot this using on the x-axis now this independent measure of target distractor dissimilarity. And what we find is that there's still a nonlinear relationship present. So even though we've kind of accounted for some of that using this independent measure of dissimilarity, there's still a nonlinearity present in this relationship. The red dashed lines in both of these plots are just corresponding to exponential fits to the data, demonstrating this nonlinearity. In experiment 2, we wanted to assess how similarity interacts with the number of distractors in the display. So we used on different trials, displays where there were 7 distractors, like in experiment 1, or only 2 distractors, as you can see in the examples at the top. And so when we plot the functions corresponding to both of these conditions, we find that this nonlinear relationship is still present, like in experiment 1, and that actually only at 10 degrees of target distractor distance do we find an impact of the number of distractors in this case. And by 20 degrees, there's actually no effect of the number of distractors. This nonlinear relationship is still present when we use the dissimilarity metric as well. And we replicated this effect in a second version of this experiment, where we actually changed the target distractor distances somewhat. So here you can see that we found a significant effect of the number of distractors now at 10 degrees and also at 15 degrees. However, by 20 degrees around the color wheel, the effect of the number of distractors had disappeared again, like in the first version. And again, this nonlinear relationship was present both when we were using target distractor distance around the color wheel, but also the dissimilarity metric. In experiment 3, we wanted to see whether or not these findings generalized to a sustained feature-based attention task. So in this task, participants had 2 sets of dots, one in the target color and one in a distracted color. And their task was to monitor the target dots for around 2 seconds each trial to detect decreases in their luminance while ignoring any changes in the luminance of the distracted dots. And so we measured performance in terms of T prime for that luminance discrimination judgment as a function of target distracted distance around the color wheel again. And in this case, better performance is going to be up on the y-axis. And we found a very similar kind of shaped relationship as in the visual search data, where as you go from 15 to 30 degrees around the color wheel, you get an increase in performance, but by around 45 to 60 degrees around the color wheel, performance starts to flatten out. We also found that there was still a nonlinear relationship in terms of performance when we used the dissimilarity metric in this case as well. So to sum up, we found comparable patterns of performance across both visual search and sustained attention tasks, suggesting that the effects of similarity may generalize across different tasks. Psychological similarity alone in our experiments didn't explain the nonlinear relationship between similarity and attention, and when we plotted performance in terms of the dissimilarity metric, we still found a nonlinear relationship. And what this suggests is that perhaps attention may act to exaggerate differences between targets and distractors, particularly for representations that are most similar, which is why we find that changes in performance matter most when you're at the lower levels of target distractor distance. And when you get beyond by about 40 to 50 degrees around the color wheel in our space, we found very little impact on performance beyond that point. So I want to thank you for listening. And if you have any questions, feel free to come by my poster session that's on Sunday afternoon Pacific time.